This is a video of how to go from this to this for a really cheap price. This video is for assuming that your third tail light on your Winnebago looks like mine, only partially lit. I think there's 8 bulbs out of 28 that are lit. That is the model number of mine, and I will show you how an inexpensive way to get this working again. Okay, I don't know if the camera can pick this up, but the front of this is really oxidized, not very clear at all, and I will also show you a really quick, easy, cheap way to make this thing a little bit better. First thing I do is I just cut off that wire. Next part might be a little more impractical for some people, but I have a stationary Delta belt sander, and I use that to sand down about 1/4 inch to where the glue on the black part is taken away from the red part, and it takes maybe 3-4 minutes, and I will show you as it progresses. Okay, I stopped right here to show you about how much is taken down, and when you take it to that point, you ground the black down to the red, and that pretty much breaks away all the glue. So when I get the rest of this done, this entire back piece will pop right out. Okay, I've sanded down the entire length of the back, and you can see that where the channel is, it's pretty well open. Just take a screwdriver, pop in there, pop this entire frame right out, just like that. And here is part of the problem, broken LED. And that is what the original LED panel looks like. And there's some extra parts down in there. But I'll get this cleaned up and then continue on. As you can see, it still has plenty of depth. Get it cleaned up and show you where I go from there. If you don't have a stationary belt sander, it's going to be a little more work for you, but you could use a handheld belt sander, palm sander, random orbital sander, or even a coarser file. Of course, going side to side, be careful not to crack this red lens. It's not real brittle, but it will break, so be careful. Removed from the first tail light that was bad. It had 8 bad, and actually, well, there's part of it missing up there, so it was a little more than half. It's about 2/3 on this one we're working, but there's really no repairing these when they're on a hard printed circuit board. So you go to your next step, next alternative. So now it comes down to a matter of choice. These are 5054, one of the bigger chips that you can get, and the 5054 stands for 5 millimeters by 5.4 millimeters. That's the size of the LED chip itself. These are red, of course, and the coating on this one is called a IP67 waterproof coat. I probably, if I did this again and I could find this chip in a IP65, I would go with that. That is more, I'm sorry about these videos, that is more of a silicone on top with a self-adhesive strip on the back. This would be far easier to assemble, but even that, I don't believe inside of this casing, inside the rail on the back, would be necessary. I don't think you would need any type of waterproofing. I think just a regular LED strip would work. The silicone's a little more difficult to work with because nothing wants to stick to it but silicone. So instead of using the self-adhesive tape, I have to use the silicone adhesive. And more on that in a bit. This is what the strip looks like when it is not lit. This is just a regular LED strip inside of here, as you can see, and it's got a silicone channel all the way around it. When I cut these, I solder up an end, and I put a little silicone on this to seal it and make sure that it remains watertight. So I will go on and show you what I mount them to. The lights that I did choose, they come on a 5-meter roll, about 16.5 feet. Again, mine are the waterproof. What you do want to look for is what's called 120 per meter. So you get 120 lights per meter. So on this reel is 600 LEDs. The reason that's important is because the original lights were 28 lights inside in that 10.5-inch area. And if you go with the 120 per meter or 600 per 5 meter, you will end up with 30 lights inside. Very important for the brightness and whatever. But every 3 you can cut these LEDs and solder new terminals on, or you can use wire clips, whatever, the quick connects for them. Soldering works best in this because of the way they come out the light. Red casing here. So out of this spool, theoretically, I can make 20, but because I was experimenting with a little bit, I can make 19 replacement bulbs. This was $6.67 off of Amazon. Like I said, these are the waterproof. If you buy non-waterproof, they're actually cheaper, but the 5054 chip is really hard to find anywhere other than Amazon. And it is the biggest chip on this width of a strip. So far, I think it's the best choice. Okay, what I mount mine to is I take a piece of just regular aluminum stock. It's 1/8 inch thick. This one was 3 foot, and it came from Home Depot, and it was $4.94, I believe, with tax. So you could get actually 3 of these mounting backs. The reason I use the aluminum and the 1/8 inch is, 1, for rigidity for the strip, but 2, it helps take away some of the heat off the back side of the LEDs. That's one reason if I redo this, I'll probably go with the double stick tape one instead of the silicone, because there's nothing between the double stick tape and the aluminum, and it really takes the heat out really well. I was messing around with some other parts, and I think that's going to be the better way. So either the IP65 waterproofing, which is only waterproofed on the back, self-adhesive strip already on the waterproofing on the front, self-adhesive strip already on the back, or the non-waterproofing, and just inside here it's going to be tight when we get this sealed up, and I'll show you how I go from here. Okay, now this is going to be a matter of what you choose. I am using the waterproof, so I have to file out a bigger notch down here for the exit of the wires. Make sure that your symbols and numbers match the other side. You don't want one side being one way and one side being the other way if you're like me. I want everything to kind of line up the way it's supposed to. So this is the symbol on the bottom of my other one in the down position. So that is the side I will cut the notch from. I take a double cut file. This edge is really aggressive. This is a double cut, and I will just use that to file on the end down here and take out a notch. Okay, I've got the notch filed in to the end, and the reason for that notch is when I put my wire in, like this. Sorry. When I put my wire in like that, it's even with the top edge, pretty much even. And the aluminum will go over that, and I will show you how I seal all this up. But that's what it's going to end up looking like when it's done. Okay, now that I've got this cleaned up from all the filings and the sandings, I'm going to try to catch how oxidized this plastic is and how it's not very clear at all. Try my best to do this, but simple cheap fix to this. Even if your lights are working, I use this product right here, and it's real light rubbing compound. I just put a little on a paper towel and I rub it on and rub it back and forth for a minute or so, and then rinse it off. Okay, I don't know if the camera is picking this up, but as you can see, this is far more clear and not oxidized at all now. Real simple, minute, and just cleans them right up. Okay, one thing I forgot to point out when I was doing this, when I was filing, I did this on a padded envelope, Amazon, as you can see, one of my 1,000. But I did this when I was filing that notch on that padded envelope to keep from scratching this thing up. Don't want to do that. And when I was sanding on the sander, or at any time you're handling this, make sure it does not slip out of your hand when you're sanding it, because if this thing would go flying off of this thing, you would end up buying one. And I priced these anywhere between, I think they were like 45, and some people were actually asking 97 plus shipping. So like I said, we're going to do this for really cheap. And this part now can go away for a minute, because you want to make sure this is really dry inside of here. Do not want to trap moisture in there. Now I'm going to start the assembly process. Paper towel, I wipe down the aluminum, wipe down the back of the silicone strip. Want to make sure that those are clean so you get good adhesion, and I will get my silicone. I use this product by GE. It's iron grip, sticks where others won't, and they just about basically don't lie. This is clear. I haven't found anything that this hasn't stuck to yet. I've had this tube for probably over 2 years. I'm not using any fine line on it, so I cut a big chunk out of the top of it, and I use a tent stake. And I pulled that tent stake out of there 30 times and put it back in when I'm done. And like I said, this is over 2 years old and I'm still using it. You want to try a rough fit first. Make sure that it's going to fit. You know, you just kind of line that up right where it's going to be. Make sure your cap and your notch is efficient to center that in there and good. But I know for sure mine's good. So I will move on to putting the silicone on. Okay, as you can see, just 5 small drops. That's all it took to hold that in place. And I have a little silicone here, and I take a little bit of silicone on the end of a razor knife and just lightly put it in. I mean, it's covering the end, but not covering the chip. Okay, I just pressed it into place. Make sure that nothing squishes out from the sides or the top. That little bit of silicone I put in wants to come out the top, so I just took the same razor knife and squared it off. Then I take the lens and fit it over top to make sure I've got everything lined up. And now that I know that the LED is in the proper position for the lens, I just gently remove it from here, let the lens dry thoroughly, and let my silicone sit up for about an hour, and then I will move to the next step. My strip is adhered to the aluminum and not going anywhere. And this has been cleaned and has dried now very good. So, well, I should say. And it's time to put this together. This is what I use to put it together. It is a brand of HVAC tape. It's foil. Peel the back off and very sticky. And this is airtight, so it will not allow moisture to get inside. So it basically even more so waterproofs the light. Okay, I cut a strip. It's just longer than the light itself. And I will center it as I peel it back, and I will show you as I go. Okay, now I have the tape down the center, and I just come to each corner and cut it in at an angle. That corner. Now, working from the sides, I just roll it over. Press it in place. Take the corners, fold them around, fold the end flap down. These corners back on that side and back around. Same with down here. I take and fold this over the connector, fold these bottom corners in under the connector, fold these over the connector. That leaves me with a small area here that's not quite covered, as you can see, and I just take a small piece and put it under there. This tape forms really well, so it's not hard at all to get it to wrap around. But as you can see, the entire piece is sealed, and got the aluminum in the back, take some heat away, and we'll hook it up here in a second and see if it's going to work. Very important on an LED strip that positive goes to positive, negative goes to negative, and I have to tell you, on the strip that I bought was actually marked incorrectly on the strip, and I had to reverse the polarity on my color wires to get it to work. But there you can see is a working taillight now. Again, the reel of lights was for 5 meters, which is a little over 16 feet, 600 LEDs. It was $16.60 some odd cents, and that was for the waterproof IP67. That was 600 bulbs, and theoretically I could make 20 lights, because I messed around with a couple pieces, experimenting what was going to work better. I can now only make 19. So you're looking at a little bit under $1 for replacement of LEDs. The aluminum bar is $5 for 3 feet, and highly recommend the aluminum. I think it takes some of the heat out, And that's about all I can say. The silicone I had, the wire is off my old LEDs, so I've got plenty of wire left to make new strips. This is a piece that I made up. This is 30 LEDs, and as you can see, it's in the silicone here, the silicone covering. But I think the next one I'm going to try, this slides right out. So now I have the LED unit itself and a piece of double-sided stick tape, boom, onto the aluminum, and I'm done. I think it will be waterproof enough inside the rail on the RV, inside the sealed up case, that it's not going to get wet. There's no way. If it does, then I'm probably underwater. But I will make up another one and carry this with me as just like an extra bulb. So if it goes bad inside here, all I do is take the tape off. I always carry that foil tape in the RV with me. It just has a million uses. But if I have this already made up and just simple solder job, puts new wires on any piece that I want to cut off of there, I have that made up and tape the new bulb in, boom, I'm done. I got a brand new brake light to go again. And on the end down here, I don't have them with me today. I've got to go get some, but I'm going to put waterproof disconnects. Basically, it's a spade and a wire terminal, and they slide into each other, fully insulated, so you don't have to worry about it shorting out. And that way, I leave the original part of the harness hooked up in the RV. My disconnect now becomes here between the original harness and the ends of this, which I'll put the terminals on. And that way, 2 screws, 2 popped off terminals, some tape, new light, and even on the road, I am back with a brand new working brake light within 10 minutes. So, hope you enjoy this video. I know videos are bad. I'm not here to produce movies. I'm here to try to give some hints and help some people out. So, hope you enjoy them, and I'll try to keep posting.